Alright, so just like I said at the end of the last video, we're going to feed this into math. So there's going to be some more rules to discuss. So just like I opened before with like, oh, here's a number, how do we know how many significant digits are in it? We run it through the rule book. You know, it's like trying to watch baseball without knowing the rules. You're not going to know what's going on. So, figures, if you don't know the rules, you're not going to know what's going on. You're going to be like, why don't they just hit each other with the bat? Or why don't they just throw the ball at the guy and kill him, and then, you know, they win, right? Like, well, that's not quite how it works. It turns out the sport is far more passive-aggressive than that. So there's not just the rule book, but a series of unwritten rules about when you tip your cap, or, I don't know, adjust your jockstrap, or spit on the ground, or whatever. And if you do it wrong, then everybody has to stand around. They have to clear the dugout and kind of just swirl around each other like they're fighting. And then usually the oldest guy in the entire group, a manager or something like that, gets knocked over, and then, you know, it hits Sports Center, and everybody has a good laugh. So, that's my analysis of baseball. Who knows, maybe they'll even play this summer. Anyway, so we're going to talk about addition and subtraction and significant figures as we go through those calculations. And the rules for addition and subtraction are going to be very similar to the rules for multiplication and division. Now, addition and subtraction have the exact same set of rules. So addition, you can think of it as like a forward process. Subtraction would be the reverse of that. You got multiplication as a forward process. Division is the reverse of that. So the rules I'm going to write here are for both addition and subtraction. Doesn't matter which one you're doing. And if you really want to twist your mind in a pretzel, you can think of subtraction as just adding a negative number, and then it's just addition and addition. So have fun with that. Just like multiplication and division could be the same thing if you think of division as multiplying by a fraction. You don't have to. It's not part of this. This isn't a math class. But if you hadn't thought about it that way before, maybe one of you learned something. Or maybe one of you learned that you are learning to hate the sound of my voice. Whichever it is. Cool. Alright. So I'm going to lay out the rule. We're going to explain it, and then we're going to do examples. And there's going to be a little side trick we have to do to explain this. So, the number used in the calculation, so whatever number we are adding to, you know, if we're adding two numbers together, whichever one that we use in this calculation, with the least precision. Okay, now my handwriting's getting real handwriting. Alright. Because I'm trying to think about what I'm writing and not so much how I'm writing it. Determines the precision of our answer. So this determines the precision of the answer. So our answer cannot be better than our worst number. That's what it's always going to come down to with these rules. And so addition and subtraction is all about precision. And so let's talk about precision for a second. We're going to do a little side trek here. So, what does precision mean? So, more decimal places to the right equals more precision. Alright? That's kind of the quickest, easiest way to explain it. So for example, if I have the number 100 versus the number 100.0, and I've tried to kind of, you know, sow the seeds of this earlier by talking about precision a little bit. One of these numbers is more precise than the other. And it's this one. Now, why is it more precise? Because it goes to the tenths place. This one only goes to the hundredths place. So this one is significantly more precise than this number. So it ends at the hundredths place. This is more precise because it, ends at the tenths place. It goes farther to the right. It reports farther to the right. The last significant digit is farther to the right. and so it is more precise. So that's what we're looking at here. So what does that mean for addition and subtraction? Well, let's say I take a measurement of two objects and I want to know how long they are when they are put together. So maybe I have, like, you know, the tuk-tuk and my beautiful bubble level here, and I want to know what the total length of them is. Something like that. And so I can measure one object, and then I can measure the other object, and then I can add those distances together, because maybe they're not near each other, maybe they're in, you know, different locations, and I can figure out what the total length would be. Totally didn't want to just show off this really cool bubble level. It goes in all directions. Apparently, this is what I left, by the way. You guys don't care, but I'm going to tell you anyway. So it's made in the USA, but it was bought for me in Australia. How about that? The carbon footprint on this thing is immeasurable, because it got shipped all the way there and back. Okay, so yeah, all the best American tools can be bought in Australia, apparently. So we got to add these two lengths together. And I'm not going to do these exact ones, but that was just an example of what I'm talking about. And so, you know, maybe we have something like 510 centimeters. And I'm going to write this vertically. I'm going to stack this vertically. And we're going to add 20.0, we'll go 20.2 centimeters. So we're going to add these up. And I'm just going to do normal addition. The math doesn't change. What changes is what we circle at the very end. So this ends up being 530.2 centimeters. That's the math. Do I get to circle 530.2 centimeters? And the answer is no. This number is only precise to the the tens place, while this one is precise to the tenths place. So my number that I report at the end, I can't report this. It goes too far. My worst case scenario creates a cutoff. And so I've got to round to the nearest 10, and so it ends up being 530 centimeters. Now you might be thinking, that's dumb. I added numbers together. I know it's 530.2. Yes, but maybe this isn't exactly 510. Maybe it's 510.3. We didn't measure out here. We don't know. Maybe it's 509, and it rounded to 510. You know, maybe we estimated it to 510, and so we have to carry that estimation through our final number. And so that's what we report, 530 centimeters. Okay. Now it's the same deal with subtraction. Now the cool thing is, we'll do another example here. When you do addition, you can end up with more significant figures in your final answer than you had originally. So, for example, let's say we have something that's 75 millimeters. We're getting really small here. And then we have something that's 50 millimeters and another measurement. We're going to add these measurements together. We get, oh, I can't quite do that. Let's say that won't work if I do it that way. 51 millimeters. There we go. This is what happens when all my examples are off the cuff. So 75 millimeters plus 51 millimeters, that's 126 millimeters. Okay? So, if I add these together, I get 126. But do I get to keep all 126, or do I have to round? Do I get to knock some sig figs out? Well, this is accurate to the nearest one. Nearest one. It's going to carry down. So that is my answer, 126 millimeters. Now our answer has 3 sig figs, but each of our measurements only had 2. So addition is pretty cool about maybe giving us a little bit more to work with in terms of sig figs. On the other hand, subtraction can be evil. It can be the devil. So for example, if I have 100.0, we're just going to keep getting smaller. We'll go nanometers. Oh yeah. And I subtract from that 99.9 nanometers. Alright, what I get is 0.1, whoops, there's a 1 there, nanometers. And I get to keep that. which is good news, because if I don't get to keep that, what do I get to keep? And so I had, what I have, actually I had 4 sig figs there, right? Because that counts. I got a decimal, so all my trailing zeros count. So that's 1, 2, 3, 4. So that's a 4. Almost fooled myself. It's okay, I can use video editing technology. You'll never know, except I'm too lazy to do it, so you'll totally see that happen. And then we got 1, 2, 3. These are all non-zero, so they all count. We got 3 sig figs here. But we only get 1 in the end. So when you subtract two numbers that are very close together, you can just get crunched on sig figs. So subtraction is evil. You should learn to hate it. Don't trust subtraction. But to kind of back up here. So these are the rules. This is the whole picture for addition and subtraction. This is how we handle our significant figures. They're not conserved. Precision is conserved. If our measurements are only good to the tens place, our answer is only good to the tens place. If it's good to the ones place, our answer is good to the ones place. If it's the tenths place, we get to the tenths place. The number of sig figs can go up, it can go down, it just depends on what we're doing. Addition, subtraction. It might not change at all. You know, we had 2 here, we get 2 here, okay, that works. But it's all driven by precision, alright? So keep that in mind. So it's a little bit tricky. And the rule for multiplication and division is going to be very similar, but there's a big difference. It's a subtle difference, but it's huge in terms of how we handle things. So just be aware of that. There's a danger zone here where things are close but not identical, so it can trip you up. Alright, so hopefully you're comfortable with the idea of precision now. This is what it means numerically, just more decimal places to the right. And then that's what we do with our math, is we just can't report more decimal places to the right than our worst number. So we go as far right as we can based on our measurements. Okay, so that's the whole story on addition and subtraction. So next we're going to talk about multiplication and division. And again, the rule's going to look very similar to start out, but there's going to be a key difference. The word precision is not showing up in it. Alright, so on to the next one.